So in this video, I'm going to solve the problem 2 to the power of 19 minus 2 to the power of 18. So I want to find the value of this problem. So for my solution, I'm going to start by rewriting my problem here. So 2 to the power of 19 minus 2 to the power of 18. And to start off, I'm going to rewrite 19 here as 18 plus 1. So I get 2 to the power of 18 plus 1 minus 2 to the power of 18. And if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 2 to the power of 18 plus 1 is equal to 2 to the power of 18 times 2 to the power of 1. And now I have this minus 2 to the power of 18. Now from here, because I have two terms that are the same, I can factor out 2 to the power of 18. So I get 2 to the power of 18 times, 2 to the power of 18 times 2 to the power of 1 divided by 2 to the power of 18 is simply just 2 to the power of 1, and negative 2 to the power of 18 divided by 2 to the power of 18 is negative 1. So I get 2 to the power of 18 times 2 to the power of 1 minus 1. And this is equal to 2 to the power of 18 times, 2 to the power of 1 is 2, so I get 2 minus 1, which is equal to 2 to the power of 18 times 1, which is equal to 2 to the power of 18. So I get 2 to the power of 18 as my answer. Now, there is actually another method of solving this problem. So going back, our original problem was 2 to the power of 19 minus 2 to the power of 18, right? And what we did was we wrote 19 as 18 plus 1, and we solved it by factoring out 2 to the power of 18. So now, what if instead of rewriting 19, I rewrite 2 to the power of 18 as 2 to the power of 19 minus 1. Now, the way I'm going to solve this is I'm going to rewrite 19 minus 1 as 19 plus negative 1. Now, I can still use that property that states that if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 2 to the power of 19 plus negative 1, that's going to equal 2 to the power of 19 times 2 to the power of negative 1. So I can still do it. Now from here, my greatest common factor from these two terms is 2 to the power of 19. So I get 2 to the power of 19 times 1 minus 2 to the power of negative 1, which is equal to 2 to the power of 19 times 1 minus 1 half, which is equal to 2 to the power of 19 times 1 half, which is equal to 2 to the power of 19 times 2 to the power of negative 1. And 2 to the power of 19 times 2 to the power of negative 1 is equal to 2 to the power of 18. Alright, so in this problem, I have 5 to the power of x plus 5 to the power of x plus 5 to the power of x plus 5 to the power of x is equal to 1,000. So for my solution, I'm going to first start by factoring out 5 to the power of x from my left-hand side, because as you can see, we have 4 of the same terms on my left-hand side, and the easiest way to go about solving this equation is to factor them out. So I get 5 to the power of x times, 5 to the power of x divided by 5 to the power of x is simply 1, so I get 1 plus 1 plus 1 plus 1 is equal to 1,000. And now 1 plus 1 plus 1 plus 1 is 4, so I get 5 to the power of x times 4 is equal to 1,000. Now, we want to isolate x, so I'm going to divide both sides by 4. So then these two cancel out, and I get 5 to the power of x is equal to 1,000 divided by 4, which is 250. So, from this large equation here, we got up to an equation that is significantly smaller. So we have 5 to the power of x equal 250, and just at first glance of this equation, we can tell that x is not going to be a whole number, because we have 5 squared is 25, 5 to the power of 3 is 125, and 5 to the power of 4, this is going to be 125 times 5, which is 625. So the value of x is somewhere in between 3 and 4. Now, to actually find the exact value of x, not just an estimate, what we're going to do is rewrite 250 as 25 times 10. And the reason I did this is because 25 is the same thing as 5 squared. So I get 5 squared times 10. And now I'm going to take the log on both sides. So I get log of 5 to the power of x is equal to log of 5 squared times 10. And this is the same thing as, well, log a times b is equal to log of a plus log b. So log 5 squared times 10 is going to equal log of 5 squared plus log of 10. Now, if I have something in the form log a to the power of b, I can move this exponent b to the front. So it's going to equal b times log a. So in this case, I have log 5 to the power of x. I can move x to the front. And I have log 5 to the power of 2. So I can move 2 to the front. And I get x times log of 5 is equal to 2 times log of 5 plus log 10. Now I'm going to divide both sides by log 5. So then these two cancel out, and I get x is equal to 2 times log 5 plus log 10 over log 5. Now, if you guys already know, log 10 is equal to 1. So now I get x is equal to 2 times log 5 plus 1 over log 5. And this is the same thing as 2 times log 5 over log 5 plus 1 over log 5. Now these two log 5s cancel out, so I get x is equal to 2 plus 1 over log 5. And although this is an exceptional answer, I want the exact answer, so I'm going to find the value of log 5. And log 5 is equal to 0.699, meaning 1 divided by log of 5 is going to equal 1.43. So 2 plus 1.43 is 3.143. So I get x is equal to 3.143. And this is my answer to this problem. And remember how we already said that x was going to be somewhere in between 3 and 4. So this proves us right.